Okay, right. Second graph on fractional part of x. Now this time this is y equals fractional part of fx. Means first we draw y equals fx and then we take the transformation. Okay. First thing we notice here, left hand side, because right hand side is fractional part. So left hand side, which means y lies between 0 to 1. Second thing, fractional part of fx equals f of x minus greatest integer of fx. So suppose my first graph is f of x equals fractional part of x square, which means first we draw x square, then we calculate greatest then we calculate greatest integer of fx, means greatest integer of x square. These blue lines we have already done it, like we have already done greatest integer of x square. So this is the situation. Like observe, from -1 to 1 graph lies between 0 to 1, between these two lines. 1 to under root 2, this fluctuates between 1 to 2, between 2 to under root 2 to under root 3, between 2 to 3. So we have already done it. Now we subtract this particular part from x square. Now greatest integer part is 0 between -1 to 1, 1 between 1 to under root 2, 2 between under root 2 to under root 3. So when we subtract this x square, greatest integer of x square from x square, value remains same between -1 to 1, which means this part will remain same because we are subtracting 0. So this is the situation. Again, one thing, whenever f of x is an integer, fractional part of it will be 0. We will see this. Now exactly at x equals 1, again at x equals 1, this is x square, which is 1, so fractional part has to be 0. Between 1 to under root 2, this value lies between 1 to 2 and greatest integer part is 1. So basically we are subtracting 1 from this particular part, which means we will bring this particular part downwards by distance 1. This is the situation. Between 1 to under root 2, this part is slightly moved downwards by distance 1. Between under root 2 to under root 3, under root 2 greatest integer part is 2, so we will bring this distance 2 downwards, which means again this part, because f of x, this fractional part, lies between 0 to 1. Eventually every y coordinate will lie between these two coordinates. Now again, graph has to be symmetric about y-axis, so you can repeat same graph exactly on the left hand side. We will do a better one when we discuss second question. Suppose second question is f of x equals fractional part of e raised power x. Okay, this is exponential curve. Greatest integer part is 0, from 0 to minus infinite, 1 between 0 to log 2, then 2, then 3. We have already done greatest integer part. I am not going to discuss it anymore. Now because greatest integer part is 0 throughout on this negative side, so graph remains same. We need to subtract e raised power x and then greatest integer part of it. We don't subtract anything when x lies between minus infinite to 0, so graph remains same. Now between 0 to log 2, this y coordinate fluctuates between 1 to 2 and integer part is 1. So we need to subtract this 1 from this part, which means y coordinate, this entire part moves downward by a distance 1. This is exactly the situation. Again, at integer, whenever fx is an integer, y coordinate is 0. So from slightly positive value towards this and then suddenly 0. Then from 0 to this coordinate 1 and then suddenly 0. Between log 2 to log 3, greatest integer part is 2. We need to subtract 2 from this line. Subtract 2 from this line, which means graph moves downward by distance 2. Exactly this. Then this part subtract 3 means bring it down by distance 3. Exactly, this is the situation. Y coordinate again lies between 0 to 1. Third question, f of x equals fractional part of sin x, which means sin x minus greatest integer of it. This is sin x. Now this is integer part. Okay, different line, okay. And then this, and then this, and then this is integer part. Okay, now observe, from 0 to pi by 2, greatest integer part is 0, which means this particular part remains same between 0 to pi by 2. At pi by 2, sine of x is 1, and whenever function is an integer, fractional part of it will be 0. So sine x is 1, greatest integer part is 1, y coordinate is 0. So immediately this is moving towards this, and suddenly 0. And between pi by 2 to pi, again greatest integer part is 0. So this part remains same except those discontinuities. Okay, now this is interesting. Between pi to 3 pi by 2, greatest integer is minus 1, which means we subtract minus 1 from this part. Subtract minus 1, so sine of x, subtract minus 1, which means 1 plus sine x. So we will be moving sine of x by distance 1 in positive direction. So move this part, this one will reach here, this will reach here. Exactly, this is the situation. At pi, value is 0. Just before pi, this is my left hand limit and this is my right hand limit. Okay, and again same thing will happen here. And now you can say this part, you can repeat this entire part because period is 2 pi. So you can just copy this part towards this and then on the negative side of it. This I have drawn cos x. This is cos x. Integer part of it is we have already done. This is the graph. Please confirm. In fact, this and this very similar except a simple translation. This was second graph. We have covered fractional part of first graph and second is f x and then fractional part of it. Okay, third would be fractional part of y equals something. Done.